Hello friends. So in today's question, block B of mass 0.5 kg rests on block A with mass 1.5 kg, which in turn is on a horizontal tabletop as in figure. The coefficient of kinetic friction between block A and tabletop is 0.4 and coefficient of static friction between block A and block B is 0.6. A light string attached to block A passes over frictionless massless pulley and block C is suspended from other end of the string. What is the largest mass of block C that block C can have so that block A and block B still slide together when the system is released from rest? So these are two blocks A and B. With the help of string, block A is connected with block C and we are supposed to find out the maximum mass for block C such that both A and B should be moving together. So now it's mentioned in the question itself that block A and block B should be moving together. Okay, but the string is connected only to block A. So what happens that block A will try to move block B along with it due to frictional force. Due to frictional force. So we can say that this is block B and this we have block A. Block A is connected to string, let us suppose the retention T. Block A will try to move block B along with it with the help of frictional force. So let us call that as Fr, and equal and opposite will be acting on block A, that is, let us call it Fr1. Okay, as there is also friction between block A and the tabletop, so there will be frictional force, let us call that Fr2, which will be acting on block A. Okay, so these are some initial forces. Later on we can find out for the individual one. Okay. So let us consider block B. Okay, so we can say for block B, so this is our block B and the force is acting on it is a frictional force Fr1. There will be in the downward direction, let us call that mbg, and upward direction there will be a normal, let us call that nb. So from here we can say that Fr1 will be equal to mu into nb, and nb is equal to mbg, so this will be mu into mbg, and here mu is already given, it is given as 0.6, so we substitute the value, we get 0.6. Mass of B block is given as 0.5 and G is taken as 10, so we can find out that Fr1 will be equal to 3 Newton. And it is said they should slide together. So we say that let block A and block B move together with acceleration So once again, for block B, let's find out what will be its maximum acceleration. Okay. So for block B, the maximum acceleration with which it can move together with block A, and that will be equal to A. So it means acceleration of, you can say, acceleration of block B maximum can be A. And for that, let's find out what will be A. So this is block B. This is FR moving towards the right with acceleration A. So we can write that FR is equal to MB multiplied by A. MB is given as 0.5, so this is 0.5 multiplied by A, and we already know value of the friction FR1. So we can see acceleration A will be equal to FR1 divided by 0.5. FR1 is our 3 Newton, so this will be 3 divided by 0.5, which gives us A acceleration will be equal to our 6 meter per second square. So this is the maximum acceleration with which the block B can move. So you can say this is the maximum acceleration with which block B can move so that it travels along with block A. So that it travels along with block A. Okay. So we can also say that the acceleration of A and B combined will be also equal to A, because they are traveling together. So now let us find out the equation for their combined motion. You can say block A and block B are moving together. So if they are moving together, this is our block B and this is our block A, and the tension T, there will be acceleration A, and we have this FR2. In the downward direction, we are going to have MA plus MB multiplied by G, and the normal will be in the upward direction, that is NA plus NB. So we can find out the value of FR2. So we can say that FR2, let me write here, for block A and block B. So we can find out FR2 will be equal to mu kinetic, and this will be into N of A plus B, and we already know that kinetic is given as 0.4, and NAB will be equal to MA plus MB into G, MA plus MB multiplied by G. So we have 0.4 into 1.5 plus 0.5 into 10. So we get FR2 will be equal to this value coming as 8 Newton. So let us now write the equation of the motion for the combined motion. Okay, so we can say that the equation of motion we can write it as T minus FR2 will be equal to MA plus MB to A. MA plus MB is 1.5 plus 0.5 and the acceleration is our 6. So we can write this as T will be equal to, we know FR2 is 8, this will be 8 plus this will be coming as 12. So we get tension T is equal to 20 Newton. Now let's do the block diagram for block C. For block C, so this is C block. The downward direction we are going to have MCG. The acceleration will be A, and in the upward direction there will be tension T. So we can write the equation for this as MCG minus T is equal to MC multiplied by A. So we can write this equation as MC taken as common, G minus A will equal to tension T. From here we can say that MC is equal to T divided by G minus A. So the tension is 20 Newton. So we get MC is equal to 20, G is 10 and acceleration is given as 6. So this will be 20 divided by 4. So we get MC as 5 kg. So this is the mass of block C. This is the mass. This is the mass of block C such that block A and block B move together. This completes the question. Thank you.